Hey everyone. So, welcome to the Chapter 2 review video where I'll discuss sections 2.1, 2.2, and 2.3. So, section 2.1, this is titled Organizing Data. So, first, what happens is there's some raw data. For example, the book, this is the ages of the 50 wealthiest people in the world at the time that the book was written. And you know, they don't say who's who. It's just every single age just thrown at you. And you can't really. It's very hard to digest the information. Very hard to get much from it when it's presented this way. It hasn't been processed yet. That's why it's called raw data. Processing the data means putting it into a more putting it into more digestible forms. That's one part of processing the raw data. And that's the part that we'll talk about here. So, given raw data, we can make what's called a frequency distribution. And so, if you'll see from this data, if we were to count everything, we could make a frequency distribution as follows. We could have a class for ages of 27 through 35, 36 through 44, 45 to 53, 54 to 62, 63 to 71, 72 to 80, 81 to 89, 90 to 98. And the frequency of occurrences happening in that class. So, for example, there's only one instance of someone being between 27 to 35. Where is it? I guess this is the youngest person. Maybe it was like Mark Zuckerberg when they made this or something. He was really young when he was very rich, so it's certainly possible. And that's why we get a 1 for that one. And then we have 3 in the next class. Let's see, 36 to 44. Here's one. And here's the other two. 36 to 44. And if you were to do this for all of them, we would see the next frequency of the next class is 9. Then we've got 15, 10, 3, 7, and 2. And this is what's called a frequency distribution. And now we've processed the data a little bit. We can make a little bit more judgments about it pretty quickly, right? Most people are, the highest amount of them were in the age between 54 and 62. The least one would be 27 to 35, right? We can make a couple conclusions about the data now. And that's part of processing the data, making these frequency distributions. So there's two types. There's a categorical frequency distribution. That's when it's not like numbers. That's when it's data, like a color or a blood type or something. For example, in the book, remember, you can look at your PDF online. It comes with the ALEKS 360 code. Example 2.1. It's talking about distribution of blood types, and it gives it gives just a table of just A, B, A, B, B, A, O, just a bunch of blood types. That's a categorical frequency distribution because it's not numbers that we're talking about. But then the second one is a grouped frequency distribution, which is something similar to what we did here. Okay, so I've got here from the book kind of a step-by-step approach for how to make... Sorry, one sec. Okay, I guess I didn't want to do that. Oh, man. Okay, there we go. This is the procedure for how to make a frequency distribution given a set of raw data. So, first we determine the classes. Usually it says... Usually you're given the how many class... In fact, always, at least I hope always. I guess I haven't seen all the material online yet. But it should tell you how many classes it wants you to make... divide the data into. So first, we look at the highest and lowest values and find the range. That's the high value minus the low value. That kind of tells us how the spread of the how big the spread of the data is. Then we it says select the number of classes desired. Usually that's given to you. I hope always it's given to you. It shouldn't be like 2 though. It should be at least 5, I guess, in probably all cases. Then we find the width, the class width, by dividing the range by the number of classes and rounding up. So there's a little caveat here I should mention. So let's do 2 examples. So let's assume we want 6 classes. In example 1, let's say we've got 4.9. Well, that means we should round it up to 5. That would be the class width needed to have 6 classes. It's important because we want the classes to all be the same width, so we're not like lopsiding data or anything like that. So that's what happens if you get a decimal. You always round up, even if it's 4.1. So maybe I should have instead have put 4.1 here. You still round it up to 5. You don't do normal rounding, which would be to 4. It's always round up. There's a second scenario which can occur, which is you get a whole number. So let's say we take the range and divide it by the number of classes, and it just says 6. Actually, what you have to do is still round it up. We add 1 to this. We round it up to 7. I know it's very strange, so I wanted to clear that up here. And then we select a starting point for our classes. You start with the lowest value that you see, the low, just call the low value, and then you add the class width to it, and that would be your first class. And then the second class, you add the class width to the upper limit, and that would give you the next class, right? And then you just keep adding the class width to get each class, and then you can start sorting the data into those classes. There are boundaries here that I'll mention when we're doing an example. We'll do an example together. Okay, so I've got an example here from the book about the ages of presidents at the time they were first inaugurated. And it gives us the raw data there. And then it's asking us a couple of questions. I don't know, I think it paused at some point. Sorry about that. So here we've got a question about the age of a president when they were first inaugurated. So the first question says, were the data obtained from a population or a sample? Explain your answer. So you have to know the difference between a population and a sample. So a population is every possible person available, whereas a sample is just a part of the population. So population means every single entry. So here, where the data obtained from a population or a sample, since it's every single president, it's not like a sample of presidents, this would be a population. Right? If it picked like, well, I guess at the age of when this book was written, it might be different. But it looks to me, especially the way that the question is phrased, that this represents the age of every single president. So that's why I'm putting here population. Okay, so now it's asking what was the age of the oldest president for number 2. 61, 69. I think it's 69. Let me just triple check. Yeah, it looks like it is. The age of the youngest president. So there's 51, 49, 47, 46, 54. Wait, what am I saying? That's higher. I see 43 actually as well. 42. Is it 42? I think it's 42. Okay, looks like 42 to me. And now it's asking to construct a frequency distribution. Use your own judgment as to the number of classes. Let's pick 5 classes. Like I said, it usually tells us however many classes it wants. If it doesn't tell you, just do 5 or 6. To be honest, that'll be fine. Unless it's like a huge amount of data and there's like a big variation, you might want a lot more. But for purposes in this class, 5 is good. Oh, I think I'm hitting the pause button, the space bar, which is making it pause by accident. Yeah, I think that's what's doing it, sorry. So, alright, so what do we have to do first? Find the highest and lowest values. This will help us remember what's called the range. The range is the high value minus the low value. We found the high value is 69, the low value is 42, which gives us 27. Okay. That's our range, remember? Select the number of classes desired. I said let's pick 5. And then find the class width. So in this case, what would our class width be? 27 divided by 5. Remember, it's the range divided by the number of classes, and then you round up. So what's that? 5.4. So we're going to want 6 classes. Remember, you round this number up. Right? 5 into 5 is 5 times 5 into 27 is 5 with a remainder of 2. So that's 2 over 5, which is 0.4. So that's our class width. And let's go ahead and make our frequency distribution. So I just want to have the naming convention correctly. So what the book does here usually is it says, I don't want to put the class limits. I just want to put class boundaries. And it can be a little bit confusing. But you take the lowest value and you kind of go half a unit to the left. A unit in this case being 1, since it's a whole number. If it was like, say, 1 or 10.1, you want to go half a unit, which is a unit in this case would be 0.1, so half a unit would be 0.05. So you'd have to move over to 10.05 would be the low bound of this one. So the way that I try to say it is you take the low value and you go half a unit to the left. So in this case, that would be 41.5. And this would go, remember, it's a class width of 6. So we add 6 to this because it needs to be a width of 6. So if we know what the low bound is, we add 6 to get the high bound. That's 47.5. And the reason they do this is so there's no confusion about where a data value is going, and so that there's no gaps. For example, you could say 100 to 104, and then 105 to 109, but that has a gap between 104 and 105, so it kind of doesn't look great. So they do it this way to make sure you know exactly where every entry is going and that there's no ambiguity. Right? You don't want to overlap. You don't want to have like 42 to 47, 47 to 52, because then which group do you put 47 in? When you move it over into the decimal points, that doesn't happen. That can't happen, and that's kind of the whole point behind doing that. So this would be our first class. Then we'd have 47.5 plus 6. What's that? 53.5. 53.5 plus 6, that's 59.5. What's this one? 66.5. Plus, what's that? 72.5. I hope I did that right. Let's see. Plus 6. Plus 6. Oh, this should be 5, no? Yeah, 65.5. So that's 71.5. I still feel like that's wrong. Let me just make sure I do this in the calculator so I don't mess up. 41.5 plus 6 plus 6 plus 6. Oh, you can't see that. Sorry. Plus 6. Okay. And so this ensures that every data point is in one of the classes, right? There's nothing outside of all the classes. So if you ever get something outside of the classes that you've got, you've probably done the class boundaries wrong. And remember, we also want to now we can calculate their frequency that we've divided up the classes how we wanted to. So it's a lot easier for me on the computer with like different colors and stuff. But I usually try to cross things out as I go. Sometimes you could use a cross for one class, maybe a circle for another, maybe a box for another, if you don't have separate colors like I do. Okay, so 41 to 47.5. So basically anything under 48. So this one, I'll cross that. 1. You have to be really careful here. There's a lot. You can have a lot of. There's a lot of room for human error, just because there's so much work to do. Um, Looks like 1, 2, 3, 4, 5, 6 to me. Then I'll do green for the next class. So anything below 54. So this one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are ways to double check ourselves at the end. Let me do another color. So anything now below 60. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17. Anything below 66 in the next one. So this one, this one, this one. 1, 2, 3, 4, 5, 6, 7, 8. And then, let's see, everything left should be bigger than 65. Which it looks like to me there are 2 of. And so, how many data values are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9 times 4, because there's 4 rows. That's 36. 37, 38, 39, 40, 41, 42, 43, 44. So these should add up to 44 because the sum of the frequencies is going to be equal to the number of data values. So what did I say? 44? That's 37, 38, 39, 40, 41, 42. Yeah, 44. So that's 17, 34, 32, 44. Yes. So always try to do that yourself when you're making these. Add up the frequencies, the sum of the frequencies, and double check if that's the number of the total elements. So that that's one way of preventing errors. There's still plenty of ways to make little accidents, but that helps. Are there any peaks in the distribution? Yeah, I guess that would be here. It looks like the peak, that's the one that occurs the most, so that's, yeah, there's a peak in the 53.5 to 59.5 class. 6, identify any possible outliers. Let's not talk about that just yet. We'll talk about a formulaic way to find outliers later. I guess any outliers would visually be on the edges, but there's a better way for that. So let's worry about outliers later. Very brief summary about it. Don't worry about that. Okay. Okay, so in this next section, we talk about another way of viewing the data. So given some frequency distribution, that's what we talk about in 2.1 is making a frequency distribution. So given that we have a frequency distribution, we can make pictures to help better view the data as well, such as histograms, frequency polygons, and ogives. That's how you pronounce that word, ogives. So what I got here is the frequency distribution for the example we just did, and I just thought we could make a one of each for this distribution. Okay, so you always want to make the actual class the x-axis and the frequency the y-axis. So this will be our class, and this is our frequency. Okay, and so here we've got 41.5 to 47.5, 53.5, 59.5, 65.5, 71.5. And the frequency, when you're making the frequency over here, just try to see what the biggest one is and then go a little bit higher than that. So here I see that 17 appears, so I'm going to make the biggest one be 20. And then I kind of tried to cut it in half. That'll be 10, and then this would be 0. Cutting those in half, this would be like 15, and then this would be 5. So now we just want to draw vertical bars to represent the frequency of each of these. So the 41.5 to 47.5 class has a frequency of 6. So let's go a little bit above the 5. How about right here? The next class is 11. I could even draw a little extra dashes, I guess. 6, 7, 8, 9, 11, 12, 13, 14, 16, 17, 18, 19. Just to make sure I can line everything up a little bit better. So that one's 6, and then I want 11, so that's about here. The next class has 17, which is here. Why does it keep erasing my stuff? Stop it. Then 8. It's around here. And then 2. Oh, I apparently forgot those ones. So 2 would be about here. And there's our histogram. Again, it's just another way of viewing the data, digesting the data. Now we can see a little bit visually the distribution. So this was a histogram. Sorry, I forgot to say what this was. It's the histogram. So next we've got what's called a frequency polygon. And for the frequency polygon, we need to also know the midpoints of the classes, because that's where we're going to draw the dot. Because since it's not an entire bar to represent the class, it uses dots. We've got to use the midpoints for the classes for the x value, essentially. So for frequency polygon, let's add in another column rather, of class midpoint. How about? And how do you find the midpoint? Remember the midpoint of two things? It's kind of like their average in a way. It's just the low value plus the high value divided by 2. So in the case of the first class, we do 41.5 plus 47.5, hit enter, and then divide this value by 2. It gives us the midpoint is 44.5. Also, we know the class width is 6, so if this is the midpoint of this class, the midpoint of the next class is also going to be a distance of 6 away. So adding 6 to this gives us our next midpoint, 50.5. Oops. Then 56.5. 62.5 and 68.5. That would be our midpoints. Remember, we need those for the point that we're drawing on the O drive. So for O drives, it's again an X and a Y coordinate. And the Y coordinate is, again, is the frequency. By the way, what was the frequency? I'm sorry, what were the classes in this? It was their age. I should represent that. It represents their age. Again, this is going to be our frequency, the Y coordinate, the X coordinate, that's our class. Again, it's their age. So let's do our we've got to list our midpoints. So we've got here 44.5, 50.5, 56.5, 62.5, 68.5. And again, the frequency, the highest one is 17, so let's just go up to 20. I'll cut it in half, that's 10. This would be 0. Cut it in half, that's 15. This is 5. So for ogives, you just want an extra data point on the edges to represent that there's nothing happening before 44.5 or after 68.5. Those midpoints. And we just put dots representing each of the midpoint, comma, frequency. And then we connect them together with a line. So at 44.5, it's 6. So that's around here. The next one's at 11. Then 17. 8. And 2. And then we just connect them with straight lines. And that is what an ogive looks like. It's pretty similar to our histogram. I kind of like histograms better, to be honest. But remember, there are those 2 extra data points on the edges to represent that there's nothing happening outside of those. And that's what's... Oh, sorry. This is what's called a frequency polygon. I kept saying ogive, but everything that this was about, this was a frequency polygon. So sorry for the confusion there. And then ogives, the next one. Ogives use cumulative frequencies. Let's again copy our frequency distribution. And for ogives, what we need is the cumulative frequency. So I'll actually put it on the right here. And we need to add an additional class representing everything below our lowest value. So I'll just put an extra row there because we're going to need an extra row. So how do I want to write this? Let me actually move this to the right. Sorry, I reset it back to what it was. Okay, so for cumulative frequency, let me just make a separate chart. Okay, that's a better idea. Sorry for the delay. So for cumulative frequency, we need an extra row. You add one extra row for everything less than the lowest boundary. So less than, in this case, it would be less than 41.5. And over here, this is going to be our cumulative frequency, which is just the added, you keep adding the frequencies up, 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 up. So it's everything below a specific value. That's why we're writing less than a specific value here in this column. And then in this column, we've got the cumulative frequency. And in this case, there were no data values less than 41.5. So this is a 0. And this is always going to be a 0 for the ogives for your first cumulative frequency. Then we'll have a cumulative frequency of everything less than the next boundary, 47.5. So how many data values were there less than 47.5? Just the 6. So this is 6. Then we've got another row for the next one. It would be less than 53.5. And how many are less than 53.5? Both of these. So we add everything below 53.5, the frequency, all those frequencies together. In this case, that would be 17. Then we'll have another row for less than 59.5. That's these 3 together. So that's 34. Then another row for less than 65.5. We just have to add 8 to the last one. That's 42. Finally, the last row, less than 71.5. And everything is less than 71.5. So this last entry should always be the number of data values. And I have to add 2 to our previous total of 42. So that gives 44. And that would be what we need for our ogive, because ogives give cumulative frequency. They're always increasing, basically, or constant at minimum, I guess. And so let's go ahead and draw our ogive. So again, we've got our x and y axes. And the x-axis, again, in this case, was age. I guess I didn't need to write class in the frequency polygon. Let me just put age here. Let me correct that. So here again, this is age, and this is, now we've got a cumulative frequency. So we've actually got to make sure we scale it based on this as our highest value, the highest cumulative frequency. So I guess I'll make like 50 be the highest. Let me cut this in half. That'll be 25. So this would be 0. Let me do it in tens. Okay, so this would be half. I'll try to do it as best I can. So if this is 40, 30, 20, 10. Let me move this up a little. That's probably better. And on the x-axis, that's going to be basically our lowest one, which here is 41.5. And then we've got 47.5. All these data values, that's what we're plotting here. And then we draw lines connecting them essentially again. So 53.5, 59.5, 65.5, 71.5. So there's nothing below 41.5, so we haven't had anything, so we have zero cumulative frequency. Then we go up to 2, so it's going to be really, 6 rather. So it's a little bit above where 5 would be, maybe around there. 17, let me label these. This is 40, 30, 20, 10. Then 17, so around here. 34, maybe around here. And then 42, 44. And then you just connect them with straight lines. And this would be our ogive for the data, or for the frequency distribution that we made here in section 2.1, this one right here. This is where we got the data from. We put the data into a frequency distribution, and then we could use that frequency distribution even further to come up with these charts, the histogram, the frequency polygon. Remember, we need midpoints for the frequency polygons, and the ogives. The ogives, we need cumulative frequencies.